Hello guys, welcome to this new video. Today we're gonna talk about Nerf. I made last week a post in my newsletter that talks about the same topic. You can find it in oriolmanzano.com/newsletter. So what exactly is Nerf? Nerf, it's a technology for 3D capture. That what it does is you have a 3D object that you want to convert into a three-dimensional shape. You want to have it in your computer as vertices, points, primitives, etc. And how this technology works is that by creating multiple images of different angles of this real object, it's able to generate a volumetric shape of this asset. This volume, it's voxels. A voxel, it's a 3D pixel, and to be able to convert that to a mesh, there's some algorithms that are applied afterwards. The important thing about Nerf is that it's currently a very good way to from a 3D real world generate 3D data. Until now, like most of our work has been to generate 2D videos from 3D environments, but right now we are starting to be able to generate 3D representations of those spaces. Just to talk a bit about the overview of Nerf. Nerf started in 2020. At that point, it was very slow. Both the rendering and the training. In 2021, there was a couple of research papers that talk about better ways to render the Nerf. This involve fastnet, black hole trees. Then in 2022, there was new ways to improve the render time. There was planoxels, there was instance NGPs. In 2023, there started to appear gaussian splatting, which was improving the quality, improving the speed. There was as well the introduction of generative AI that was not just allowing to generate 3D meshes from existing images or videos, but also be able to generate them from scratch. In semicolons, like to train the model, you need, of course, data, and there has been a very good data set that has provided that. In my tests, for my personal projects, I've been using ModelNet, I've been using PartNet. ModelNet contains a very good amount of 3D meshes of all shapes, while PartNet, it's the same, it's just that they are in partitions. So for graph algorithms that can take into account the hierarchy of parts, it seems more suitable. But anyway, like going away from the generative AI part, all this Gaussian splatting and Nerf, all these algorithms that is able to generate this volume and later on the mesh seems pretty cool for visual effects and for all other industries as well. They are starting to get very accurate results, including lighting, materials, and you can at this point start to make modifications to the volume itself. So before, most of the modifications, imagine, let's put an example of a big city that is in the summer, and you want to have the city full of snow. To do that, most of the work until now has been to edit the 3D geometry that has been generated from the volume to include this snow, to include these new textures, this new geometry that might be required for that environment. But recent works has demonstrated that edit directly the volume seems to be giving much better results, which is something very very, very interesting. And also it can allow to track and extract data from these points. Imagine you have an environment, right, that you're just recording with a camera, and you say there is this person there that I want to remove it. It's just easier to use object recognition techniques to detect where this person is located, to be able to remove it when it's still a volume rather than later on. Or if you have a robot that has to detect objects, that has to detect how a machine works, has to like move objects, move things. If it's able to detect the position of the objects and the orientation and everything in 3 dimensions, it can have much better accuracy. I can also see it very useful recently for not to remove the movement of a video. Let's say you're recording something, you're recording in the street, you're recording in an inside space, and you're moving the camera around. This movement is gonna be appearing in the video. What if you don't want? What if you want a smooth transition? What if you want a smooth movement, but the video is already recorded? If you are using these volumetric techniques, you could generate a volumetric space of this environment that you have recorded and reschedule the camera to the orientation that you wanted and get results that it looks like it was recorded in that direction. So that's very interesting. The part that I believe that we are still missing with all these technologies is the multidimensionality. I've been reading different research papers about the topic, and there is not that many people that is including sound, that is including 4D. So when I mean 4D, I mean like moment. If we have to record a scene, there's gonna be people moving, there's gonna be animals, there's gonna be cars, whatever. Like there's gonna be objects moving around, and all these reconstruction techniques, they are not supporting this movement. There is of course like some people that are starting to make changes to that, and there is 4D research going on. I've seen some reconstruction and tracking of humans for video, and there is as well Wonder AI that is decoupling the human and camera motion, so you can extract from the video the full movement of the human, but there's still lot of work to be done in this field. And another problem that I think it's gonna start to happen is all the 3D data that we need for those models. Until now, we are fine using these big data sets that some people have generated as ModelNet and BaRNet. But what if we need to train a very big model that has a lot of neurons? Those architectures requires a lot of data, and I've started to see a lot of people that are moving to synthetic data sets. There is companies that when they have to apply generation of models, they just synthesize their data. This is done in visual effects, this is done for autonomous cars, this is done for every industry, and I think it's gonna take more and more importance in the next months and years. That would be it for me. Enjoy your day.